Don't put it in front of the 10 and log it.
Yeah, we'll take the log of both sides, right?
Yeah.
This is an exponential equation that you have to solve, so we turn it into logs, right? So we take the log, both sides. Okay, so we get 2x plus 3 out front because our property of logarithm says we can do that, right? Since we turned it into log, times the log of 10 equals the log of 315. Okay, so the next step is to take the log on the left, this log of 10, to the other side. How do I move it? Divide, right? Because right now it's being multiplied. So that on this side it's gone. Oops, on 315 again. All right, so we're going to do log of 315 over the log of 10 on that side in my calculator. So that leaves me 2x plus 3 equals log of 315. Remember to close it off. Divided by log of 10. Close it off. So we got 2.498, so we'll just leave it as 2.5. Okay, and then we'll finish it up. So subtract the 3. Okay, just like that. Subtract 3. 2.5 minus 3 is a negative half. And a negative a half divided by 2 is a negative a fourth, right? So that's our answer. Now we could check it. So we go back to the original problem and put negative 0.25 in it. Now it's going to be a little bit off. Why? It won't give me exactly 315. Why? Because I rounded, right? Okay, if I could have put down the exact answer, I'd get closer to 315. So, you know, you just put in your calculator 10 to the, and then it's going to be 2 times negative 0.25 plus 3 power. All right? And that's going to be close to 315. It won't be exact. So it gave us 316. That's pretty close, right? Okay? So that's the exponential ones. You guys are pretty good at those. Let's do, oh, that's all right. We'll just do this. We're doing basically the same thing this week in CP. All right, so number 1 for your practice quiz was 25 to the x minus 3 power equals 125 to the 3rd power. Again, this one we could rewrite with the same base of 5, okay? But again, I told you, don't worry about trying to figure that out. Just take the log. All right, so we're going to put the x minus 3 in front of the log of 25 when we take the log. And then you can, I like to put the exponent in front, so 3 times the log of 125. Some people just take the log of 125 cubed. It comes out to be the same thing when you do this. Okay? And divide both sides by the log of 25. So don't forget about that 3 there. Okay, so on the left, I'll have that x minus 3. And then on the right, when I do that, I get 4.5. All right, anybody having a problem in your calculator, 3 times the log of 125 divided by log of 25, being 4.5. Then that's just calculator work. So just add 3 to both sides, and you get 7.5. Questions on the first one? Hopefully you all got it right. You know how to get it right now? Huh? Maybe. How did I get that this time? Number 2, just like number 1. This one also could be written with a base of 4. So if you're one of those kids that are good at doing that, realizing that, I think we could have used 2 also, a base of 2 or a 4. But again, I like doing, we could use a base of 16 actually. Because 16 squared is 256. All right, but I just did logs again. So again, the exponent times the log of 16 equals the exponent times the log of 256.
Unplug for a second, so it doesn't skip when I'm writing. Hopefully that works.
Okay, so I'm going to divide by the log of 16. I always like to take the log on the left over to the one on the right. But it wouldn't be wrong if you took the log of 256 over there. All right, so the log 16 on the left cancels, so the left is just x. The log of 256 divided by log of 16 is 2, I believe. Let me check that. Okay, so I have 2 times x plus 4 then. Okay, so I got to distribute that 2 on the right side then. Cole, did you get this right?
What was the answer?
I don't know, what'd you get?
-8.
Correct, you're right. All right, so subtract 2x from both sides. And you get negative x equals positive 8. We don't want to know what negative x equals, right? So basically what you're doing is dividing by -1. So we know what positive x is. And it's okay to have a negative answer. You can check it if you want. Go 16 to the -8th power and 256 to the -4th. Let's see if you get the same thing. And you will. Questions on number 2? Okay, number 3. This one, you would not have been able to rewrite with the same base. This one you have to take the log of both sides. But again, I just do what we've been doing, x minus 3, the exponent times the log of 7 equals 3 times the log of 23. And then divide by the log of 7. And you get x minus 3 equals 4.834 is what I got. I run to the hundreds. 834, sorry. And then just add the 3. So when I add 3 to 4, I get 7. So you won't always get nice whole numbers, that's okay. Again, if you had 7.8, that's fine. Okay? So those are the three exponential ones. Questions? All right. The logarithmic ones. All right, what we like to do with those, we turn the exponentials to logs, and then we're going to take the logs and turn them into exponentials. So log base 3 of 2x plus 3 to the 4th equals 16. Okay, if I have an exponent like I do this 4, I always like taking it to the other side of the equation, so I don't get as big a numbers. Okay, but some of you might have written this, 2x plus 3 to the 4th equals 3 to the 16th power. That's okay. All right, but I like to get my numbers a little smaller. So whenever I have an exponent, like I do here, I always move it here first, and then I move it to the other side. Okay, so that's what I'm going to do. So it's going to be 4 times log base 3 of 2x plus 3 equals 16. Now, how do I move that 4 over to the other side? Divide, yeah. So then I get log base 3 of 2x plus 3 equals 4. Colon.
Yeah.
You bothered me. Sorry. All right, so now rewrite it. Trent, focus.
All right.
The number 2x plus 3 equals the base to this power. That's our problem now.
How did you do that?
We learned this.
I know you had the 4, but what'd you get? Why did
B
you
to the x equals a is log base b of a equals x, right? Those are equal. We learned that right when we started these. So whatever this base is, to that power equals that number. All right? Whatever that base is, to that power equals the number after the log. Okay? So then I can just solve it now, because 3 to the 4th, I know I can put in my calculator, or you might be able to know it already in your head, but that's 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. And then there's basic algebra 1 stuff, right? Subtract 3. And divide by 2. And you get 39. All right, so again, I like moving this exponent in front, that 4, and taking it to the other side. So I got 3 to the 4th. That's a lot, 81's a lot smaller than 3 to the 16th. And then I got something to the 4th power. How do I get rid of that 4th power if I'm solving an equation? Now, square root, if it's the 4th power, the cubic is the 3rd power. It's, well, whatever, yeah, we don't have a special name, but we take the 4th root, right? Which you could have done. Okay? But we'd have to take the 4th root of both sides. So whatever 3 to the 16th is, we take the 4th root of that. And it would still work out. We still, once we solve for x, we get 39. But you're running into some big numbers if you go 3 to the 16th. So that's why I move that exponent. I always like moving that exponent over so I don't get quite as big a number. And then I'm just looking at trying to solve for x, not solve a fourth root of sum to the fourth or sum to the third, whatever. Harris, put your phone away. Now, number 5, I have 2 logs. So what's the first step, Sammy Joe, when I have 2 logs? Yeah, but because we want to make it into 1 log, yeah. If we have multiple logs on the side, we want to turn it into 1 log, right? And like Sammy said, we're dividing because this is subtraction. If this was addition, I'd do what with the 2 numbers? Like multiply, okay? So I'm going to rewrite this as log of x squared minus 6 over 7. That's a division problem, right? What's the base of this log? 10, right? So this number, x squared minus 6 over 7, equals 10 to this power, 10 to the first. Okay? So what do I do first to solve that? Right, multiply both sides by 7, right? And those cancel. So I have x squared minus 6 on the left and 70 on the right. Plus 6. Now I got an x squared, so what do I got to do? Square root it, right? So this one we did have to square root, we couldn't avoid it. So plus or minus. And my direction said you should round to 3 decimal places, didn't it? You guys ever even look at that? You guys should read directions. So to 3 decimal places. Oops. Didn't look good. So 8 point what? 718.
We are short.
Now, do both the plus and the minus work?
No.
Well, if I square a negative, what type of number is it? Positive. And if it's 8 squared, it's going to be 64 minus 6. That's going to be a positive number, right? So both of them actually work this time. Both the positive and the negative. Because I'm still taking the log of a positive number up here. Okay? It's just you can't take the log of a negative. So that's why we check those to make sure. So both, quit doing that. Both of those answers are acceptable, positive and negative. All right. Number 6. That's another one that's got that exponent in it, like number 4 had. So log base 4 of x to the 6th equals 8. Now, some of you might have written x to the 6th equals 4 to the 8th. That's okay, but you got big numbers again, right? So I like to move that 6 out front, multiply it, and then move the 6 over by dividing. So then I've got a little bit smaller. X to the 4, x base, I'm sorry, log base 4 of x, and that's 4/3. So then x equals what? 4 to the 4/3, yeah. Okay, you put that in your calculator. 4 caret, parenthesis, 4 divided by 3. So 6.35 if we go to 3 decimal places, right? 9.6 makes that a 10, so I gotta make that a 5, right?
Yeah.
6.35. If you left it as 4 to the 4/3, I'd give you credit. So again, you're not wrong if you did this. If you said x to the 6th equals 4 to the 8th. So then you could have done this. 4 to the 8th, and you got that big number, 65,536. Now, what do I got to do to get x? The 6th root, right? Right? Watch. It'll still work. All right, the 6th root, to do that, you hit the number 6 first, then go to math, and use number 5. That's telling the calculator you're putting a 6 right here. And then we'll just use that answer, second answer. And there's your 6.35. So it wouldn't work that way. I just don't like using really big numbers, that's all. That's just me. Questions? Is this helping?
Yeah.
We're gonna be ready on Thursday?
Of course.
You might see some of this stuff tomorrow on the ACT. All right, so yes, we are having it. So make sure you're prepared by paying attention today instead of zoning out. Now, you guys see LN and you just say, oh, I'm not sure what that means, so I'm gonna put a little question mark there.
I know it.
Why? Does it matter what is here? If you have a log of something equal a log of something, no matter what the base is, you just cross out the logs, right? You just drop them. That's all you gotta do. That's natural log. What's the base when it's ln? Not 10. Max. Because a regular log with no number is base 10. Ln, Brian, since you've been studying all this, what's the base for natural log?
We just said it. No, is it one?
Yeah.
E.
I like log and natural.
Natural log is when the base is E.
Oh, yeah.
Yeah. Okay? So, subtract x. Let's keep our x positive. Subtract 8. So I get negative 12 equals 3x. Divide by 3, I get negative 4. What happens when I check the negative 4? What's a negative 4 minus 4? Negative 8. Can I do the natural log? Right there it is under log, natural log of negative 8. No. So we did everything right. Okay? But this has no solution. Because negative 4 really doesn't work. Okay? So number 8 is another natural log. Again, I use capital L because if I don't, it looks like N-I-N, so.
Like a function.
I don't think so, but it just, a lot of people think it's N instead of LN, so. All right, so I have two natural logs on the left. How do I make it a single log? Divide, all right? What if this was addition? Make it 10 times x, right? So it's natural log of x divided by 10 equals 9. What do we say the base was for this? E. So what's my equation, my exponential? X over 10 equals e to the 9th, yeah. All right, that's all that means. All right. If that was a regular log, it'd be 10 to the 9th, right? If it was log base 2 of x over 10, it'd be 2 to the 9th, right? So the only thing different, since it's ln, is the base is e, that's all. Now, how do I solve for x, John?
Don't you multiply 10 and 9?
Yeah, 10 on both sides, right? So my answer is 10 times e to the 9th. All right? You can leave it like that if you want, or you can put it in your calculator. All right? So 10, how do you move e to a power? What do you hit? Second ln, right? Isn't that what we're going to use on this last problem? Right? The last one with the word problem? All right? Or you can go e, second division sign, caret, you can do it yourself. 9, close it off. 81,030.839 to the nearest, 3 decimal places. Oh, 81,030. 83,030. Thought I did something wrong there. Questions? Number 9, if you miss it, I'm going to smack you upside the head. Why? I gave you the formula, didn't I?
Yeah.
So don't put it in wrong. All right. So what's P in this problem? Right, that's our principal. That's the original amount we start with. E to the, what's our rate? 0.105. Remember, move that decimal point 2 places to the left. And our time was 14 years, so times 14. Okay? So, again, going back to my calculator. 1,200. Second natural log for that E go in there. Some of you forgot the E part. Okay? And then the 0.105 times 14, and then close it up. I have to close it up. Some of you, it just puts it up there for you. Hit your right arrow key. And we get $5,219.08. You should go to the nearest cent on money, right? So, this is not that difficult. You guys are making it harder than it is. All right? Do you have any questions about any one of those that maybe I didn't skip over for you? Didn't catch? All right, is it gonna look much different than this on Thursday? No, not much different at all. So, practice. Do good on your ACT tomorrow.